Hi, today I would like to discuss on problem and issues in teaching and learning emerging new concept in biology, which is I focus on biomedical engineering. I am Alfera Poly, and this is for assignment 1 for the emerging new concept in biology. As you can see from the picture here, there is a science engineering and human living system which integrate and combine together. That is a short introduction for biomedical engineering. So the first issue I'm taking from La Placa, which is published on the year 2001. As you can see from the paper, they are saying that the multidisciplinary nature of the field demands that students develop multidisciplinary skill and knowledge, which is we know that our typical engineering student, they will analyze the world to set constraint and design, and our typical biology student, from the hypothesis, they will conduct experiment and give an explanatory accounts of the phenomena. However, when these two are combined together, a student need to be exposed to product design, development and manufacturing, regulatory requirement, clinical studies, and multidisciplinary environment, which is I think is very high order thinking and require cognitive flexibility and true interdisciplinary thinking. In Malaysia, we still have a syllabus that is a traditional syllabus academic, which is not helpful to cognitive flexibility and true interdisciplinary. So when our student taking BME, they will have no experience or lack of experience in topic of modern BME. So that is our first issue. The second issue is from Harris et al., which is published on the year 2002. In this paper, they give 4 barriers. The first barrier is the biology engineering barrier. They believe there is a gap between biology and engineering from student background. As you know, our engineering students heavily influenced by mathematics and physics, and our biology students rarely integrate biology with calculus. I believe that biology students have learned about mathematics, modern mathematics, additional mathematics, and physics subject. However, and I believe that our physics students are learning about biology subject. However, there is no integration of syllabus between these two subjects with biology or biology with these two subjects. And the student who taking BME will have difficulties inherent in applying quantitative method to living system. And they also have a time constraint for students to achieve a meaningful learning. That is the first barrier. Second barrier is the learning science engineering education barrier. What they're saying is that in our history of education itself, our engineering is on-job training, which is our engineering student a trend to be a professional or expert in their field, and they are rarely to develop a new technology which is combined with medicine. And a typical member of faculty, which is a lecturer, only prepare for a career in higher education and their own field of interest. That is a second barrier. The third barrier is that a technology education barrier. In this paper, they are written in 2002, and they believe that engineering faculties still have skepticism on using technology. This is due to the inavailability of good material. That means when they are conducting a biomedical, they still have no good materials to combining these together. And then there is a lack of proven efficacy when they are combined biomedical with engineering. So they want to reduce the failure of the product and reduce the cost of the failure. Okay. Barrier number 4 is the academic, industry and practice barrier. Still, during this year, there is a separation of industry and academic work. We have a few large biomedical device companies exist, however, only a small companies with few resources dedicated to academic cooperation. When there is no cooperation between industry and academic, there is no development of the biomedical engineering product itself. So that is the 4 barriers and issues or problem from Harris et al. So the third journal I'm taking from the Sanka and Alme, which is published on year 2015, focus on Bosnia and Herzegovina. So the first problem is that a common disagreement and misunderstanding about the biomedical engineering definition. BME before this known as an instrument developing maintaining medical device and related to electronics or biomaterial. And during a few decades, they are evolving and diverse fields as electronic telecommunication, computer and software engineer, computer science, mechanical engineering, and chemical engineering. However, in this 2015, the BME need to bring together 2 demand fields, that is biology and engineering. That is very hard to combine it together due to certain ethics or certain difficulties. Not only during education, which is students require a multidisciplinary knowledge, but also during the professional work, this is due to the lack interaction between experts in engineering and medicine. What happened? A lecturer which is expert in engineering, they have no discussion or round table with the lecturer in medicine. So this will giving a problematic when they are conducting a biomedical engineering education. And the lack of a modern technologies of laboratories will be another problem for a biomedical engineering student when handling their experiment or handling their instrument. The second issues from this paper is that the importance of medical ethics relation to study programs in other engineering discipline and health professional. What they are saying is that they need a confidentiality in the professional relationship. They need to resolve conflicting issues between personal belief, and they must have ethical consideration. Which is I'm saying that when they are talking about the ethics, the bioengineering or biomedical engineering not only with the ethics of engineering, but also with those of biology, medicine, and the physical science, the field with which bioengineering interacts most strongly. For example, in the physical science, the ethic is how do researchers obtain and verify the knowledge. In biology ethic, how can this be done in the context of living organism, and what is the nature of the life, including the body-mind problem of consciousness. In medicine, what is the nature of disease? In engineering, what is the nature of the machine? Why are they machine? And how far can humankind go with machine? For example, in making them self-reproducing. So with this ethical consideration, the student need have a good multidisciplinary knowledge and skill to have a good results in biomedical engineering education. Not only result, but the products and instrument. So, in conclusion, there are 4 issues I giving based on 3 papers. The first one is multidisciplinary skills and knowledge, barrier of science, biology, faculties, industry and technology, lack of expertise interaction, ethical relation between engineering and medicine. So from these issues, teaching and learning of biomedical engineering, I hope that we can overcome these issues and problems and to diverse the biomedical engineering to help humankind when conserving and preserving the environment and health. So that's all for me. Thank you.